All right, we're going to plow right on through to Hamai's next one, which is the Ceph 0-day for performance regression. So I guess go ahead and jump right in.
Yeah. Okay. I want this topic is about performance things about the whole Ceph project, and maybe a little and we want to address this existing problem. We think among the developer Ceph, and we do Ceph class the DevOps. And I think we lack a necessary way to evaluate a performance improvement preset. For example, if someone give a performance improvement preset, we can't give a mostly we can't give a detailed number about how much this preset give, and do this preset will affect other components. For example, maybe we consider to improve read write performance, but actually we hurt sequence write performance. Maybe it is just a good example. And the second is unknown performance degraded for unaware future preset. For example, from dumping and to hammer, and we get many performance improvement. For example, for fast dispatch and the PG sharding and the something at fast store. But actually, we don't get enough improvement where we release hammer version, and we found some maybe some other patch set affect the performance, and we can't see how this where is the patch set effect. And the third, actually this is a same problem. We have some performance killer, but we don't know at the past merged PR. And the fourth is actually it is for users. Some users have some customers confused, but where he upgrade, he will find the performance degraded, because different version will have different configure view effects, and maybe for example, such as fast store threads or PG threads. We need to improve PG threads where we upgrade to Hammer, because we have much more computer time, and we need to more op threads compared to before if we using the same backend HDD. I think so. We want to get the performance expectation, and we don't want to make us unknown to the unaware performance killer. So how we avoid this problem? I think at first we need to have a performance test class which is stable, and we need to do daily or per PR performance test run, and we could like need a QA label for GitHub PR. We need to need a perf label for performance related PR. Maybe it is not a performance patch set, but we need to add this label if we think it is affect performance. Maybe if, for example, if we change the mean IO path for PG codes, and we need to add the perf label, and we need to easily to get the performance result before merging performance patch, so we can have confidence to say that this is actually improved. And I think how we do this, and I know Intel has a project called Satan, and maybe we can cooperate this But before this, I don't have detailed architecture about how we do zero-day performance benchmark. I don't just give some ideas about it. So at first we have a test cluster. Maybe we can use a simple self-display or using QA test framework to do this. Both is okay before we actually do this later. And then we have workload generation. The first class is FIO LZOO or ZSKDW benchmark or relevance bench or ID bench. Maybe we can pick some of these, and then we could run some critical unit test program such as, for example, CSE or module internal benchmark, for example, librd benchmark, but the benchmark don't touch OSD. So it means maybe we could mock the librd, and we can let the librd doesn't send a request to OSD actually. We don't let this loop back, and so we can benchmark the librd itself. And the third, we can add some new test, just like existing self-perf programs, such as self-perf object store, self-perf message, and others. So this is workload generation, and we need to have metrics. For example, the basically is runtime. For example, how much time we run a test, and we need to gather this runtime. And the second, we need to gather the self-perf dump for some numbers, and it depends on the detailed test. And the third, if we run FIO or LZOO, this high-level benchmark, we need to collect the system metrics. For example, we need to collect things from L state and kernel things such as label info and net perf or CPU usage, memory usage, including disk usage and disk detail about the detail BLK chunks or F chunks and NUMA things and Vim state or other things. I think because for example, if we want to do performance improvement for fast store, maybe this is related to BLK chunks. We can see how much we can reduce for disk sync halt or sync time. So at last, we need to have some program to automate to compare two perf results and give a conclusion about the page set. For example, how much is this page set make performance stable or make LPS less strict? For example, if original LPS is unstable, it is maybe sometimes is 100 LPS, sometimes is only 15 LPS. So we need to make this metric available. The second is the detailed performance degraded or improvement for the patch set. For example, original we can get 100 LPS, and later we can get stable 300 LPS. Yeah. And the third is runtime. I think it is simple. Yeah. So from this we can get a framework about how to I think how to do self performance benchmark test, and we want to make it is highly automate. So I think this is some guidance about how to set up this infrastructure, and we need to some hardware. For example, maybe we don't need too large test cluster, but we at least we need to 3 or 5 physical machine to do this, because VM maybe not good enough to test this because VM itself has some problem for performance benchmark, and maybe it can give some raw result about the performance. And then we need to run a test cluster daily and give a report to the PR and on MailList or on GitHub. Then at first we need to focus on basic IO paths, and for example, we focused on Firestore and the PG things and the simple message and maybe librd without catcher or enable catcher, and the Redis gateway with the S3 and CFS. So we can reduce some tests at the early stage. And the next, we need to add some more module internal tests. For example, as I mentioned before, librd without sending request to cluster, and object store with FIO, and the PG IO path benchmark. It is maybe an internal benchmark test program. So this is all. This is already a Linux 0-day performance set up by Intel, Wu Fengguang. This is a little alike, but it is for Ceph.
So I did want to point out that there are a couple of somewhat more convenient workload generation tools. There's a Ceph small IO bench, and it can be run directly against the. Oh, Syed was here. The person who just left, I think, was the person you want to talk to about the queuing. Anyway, what was I saying? Right, small IO bench has a version that runs directly against Rados, and it has another version that runs directly against the an object store implementation. So those might be interesting places to look. Also, I think there's a dummy librados floating around, right, Josh?
Yeah, there's also so a while back, Jason made a dummy librados for running RBD tests against and unit tests in general. I think there might be some performance tests that we can run against that as well, just to benchmark librd itself or the client side in general, without involving the full stack. And
wait, you wouldn't test the objector, right?
Right, it wouldn't test the object. It would just be
okay. So it would test RBD and RGW.
Yes. Yeah. Right now it's only set up for RBD, but it could be modified to work for RGW too.
I think RGW has already a load gen that Yehuda has written, so that is we are using that, and that's actually quite extensive. So it can actually catch any regression within the RGW part.
This would be a way of testing the testing RGW without a Rados cluster, so that you could see exclusively the CPU overhead of Rados GW.
Yes.
Okay, what was the other thing? I would like to point out, since Mark isn't here, that if you create a simple Ceph deploy script, what you get is the Ceph benchmark tool once you solve all of the problems inherent in that. I would
I use it. But
like to suggest very strongly that you make it a toothology tool and not roll a third cluster setup system.
Yeah. Maybe we can cooperate existing some projects such as CBT.
No, I think you should do it in Rados. CBT is cool, and that might be an appropriate thing to do later, but we'd like to be able to run this in a more lightweight fashion. CBT is more for setting up, we'd have to ask Mark for more details, but more for setting up larger, more complicated tests where you want to set up, run a bunch of different parameter combinations. But we're looking at running a specific set of combinations reliably over time with very little effort.
Okay.
Hey, actually, this is Jian from Intel. We are trying to build a self-performance portal, just like the Linux performance portal. And we have some early results on a single UP cluster and a DP cluster. Our target is actually we only focus on the major release performance. We don't seriously taking the performance of each pull request. And we probably will test the master performance on monthly basis, and we will use FIOL workload to test RBD performance, and using the cost bench to test the object performance.
Sounds good.
Okay.
It's pretty.
Yeah, I think
pretty the same goal.
I think this is meant to help a developer or maybe not help users. I think this is the goal of the Ceph 0 day. Maybe we need to help a developer to do performance things. And before we release the Ceph to the users, we need to address the performance things in the PRs.
Yeah, and how that's the other thing. If it's written as a Rados or as a tautology task, or as a suite of tautology tasks, we can roll them into the Rados suite and RBD suite and RGW suite.
Yeah.
Yep. I don't know that we'd want to have fail if numbers are wrong, but then we'd have a historic log of what various branches have scored at different times. And then after a short period of time, we should be able to actually build that into a pass or fail thing, so we can detect regressions, which would be nice.
Yeah, so I don't know if you guys saw the session yesterday on non-functional testing. It was also pretty related to this. He was working on some similar ideas using this tool called Aver.
I just see the PDF and the paper, but I think it's a little difficult to set up this. Yeah, I think we maybe just want a simple one to work. Yeah.
Mm-hmm.
I kind of think that the tautology test is very heavy for 0D performance. It usually takes like probably several days to pass the tautology test, especially for the Rados suite, right?
Well, for the entire suite, but that's several hundred tests. The single task, one of these single tasks, yes, would be shorter. But I don't see any way to do hundreds of performance tests that would take less time than that. I mean, it doesn't. You don't have to run the whole suite. You can use a filter to run a single task if you want to.
Okay.
Well, the issue is for tautology tests, the setup is very, very small, I think. Usually there are only 3 or 4 OSDs. Will this be an issue?
Okay, so there are several different. The length and breadth of ways you can do performance testing is kind of astonishing. So if what we're worried about is code level regressions in something using too much memory or taking too much CPU time, then we actually want a small cluster, not a big one. Big clusters have a tendency to hide problems behind big walls of CPU. That would be easier to show up in a small test. However, if we're looking for something like a scaling bug where we're opening too many connections per OSD, something like that, you're right, that wouldn't show up in a 3 OSD test. But on the other hand, it would also take a lot more resources. So we'll want both, but the tautology one is still valuable, and bonus, we can do it as part of the normal Rados runs. The ones that take 20 or 30 OSDs and a data run would be hard to integrate into the usual runs. So we'll have to live with a little less coverage on those.
But the problem is that there are a lot of changes that only benefit in a small setup, but not benefit in a larger setup. For example, for the XL messenger, the async messenger in our test result, it helps in small scale, but doesn't help in large scale. So if you don't test large scale, you never see the problem.
No, we'll still have to test the large scale. I'm saying it's valuable to have the small scale also, because we can run them more often.
Yeah, I think we can address most of the
problems. And that the large scale also hides things. So we need to do
this
both.
is another problem.
Yeah, and another problem is that in tautology test we can combine a lot of patch sets into a single run, but in the performance test, seems we can't do that. So, and the performance test is sometimes very heavy. For example, if you want to do some read test, you need to
build out a big data set.
Yeah, you need to prepare the data. That is very heavy. So
the other problem is that the machines aren't necessarily super uniform. That's all true. We may not want to build them into the actual suite, but it's still valuable to structure them as a tautology task, because that way you don't have to rewrite the part where you pull from the YAML file, the particular branch you want to run, find it built in the repository, pull down the packages, install the packages, set up the cluster and the mons, distribute keys, set up SSH. It's just tedious and annoying. All of that stuff can be handled by Toothology. Toothology can do bigger clusters. It's just that we don't in the normal suite tests because then they take forever. We actually have a big suite in there. It's just not run regularly. So yeah. Does that make sense?
Yeah,
I guess I'm arguing for Toothology as the orchestration framework rather than Toothology as the usual way the YAMLs are structured, if that makes sense. Plus, if speaking as just a developer, it's really easy for me to run Toothology tests. It's really hard for me to go to a site, read a bunch of directions on, first I need to pull some machines out of a thing, then I need to set up an orchestration framework, then I need to set up a Ceph cluster, then I need to run this new framework against it, which is, harder. It would be easier if we could just use the existing structures.
Yeah.
And that's not to say that we couldn't make this easily runnable outside of Toothology too, and just have a Toothology task that goes and calls it.
Yeah. I mean, the part that actually runs the workloads and then compiles the results has nothing to do with Toothology. I'm just suggesting that we use Toothology for the actual day-to-day nuts and bolts running of it.
Yeah, I think that makes sense.
Yeah, but what is the process? I mean, we can imagine that there will be a lot of pull requests that will be marketed as performance related. So yeah, it seems that since we cannot combine them together to a single run, so that will take a very long time. Or how can we manage the merging process?
Yeah, maybe just as need QA things, we could bunch up multi PRs into one single run. So maybe it is a daily or maybe some hours. Yeah.
In QA you can do that, yeah, but in performance you cannot do that because you don't know which PR caused the issue.
No, you can do it. You can do it for the same reason that you can do it in QA. If you find an issue, then you have to pull the package of PRs apart and this is before you merge to master, by the way. This is an integration branch. So you start testing the individual ones or inspecting them and removing them based on a guess until you find a clean subset, merge that, and then go back and figure out which one was broken. You're right, it's not perfect, but I mean, performance testing always takes a lot of resources, so it'll be really difficult to do on an every PR basis. Certainly if you want to do the 20 OSD or 40 OSD cases, which we probably won't be able to do on even that basis.
Yeah, but
go ahead.
But I mean, we understand the code, so if you see the assert failure or node failure, you can easily tell which PR caused the problem. But if you see a performance degradation, it is harder for you to find which change caused the performance degradation. And
this is it's
very hard for you to pick out.
It's an optimism versus pessimism trade-off, right? So it costs you more time in the case that you do find a performance regression, but it costs a lot less time in the case that you don't, right? Because you can always fall back to testing every PR individually, but if you get lucky and nothing caused a performance regression, then yay, you get to merge it after one run instead of 10.
Yeah, another problem is that maybe maybe we usually do some kind of trade-off. So if a PR can benefit some read performance but hurt a bit on write performance or something like that, what is a trade-off?
We need to discuss. Yeah, we need to discuss. So I think
that's assuming we even detect it. So that you said rel versus Ubuntu, that means you'd have to expand the test matrix so that you caught that, which I don't think we can afford to do. We'll have to, I suppose, be careful.
Yeah, I think
usually that'll mean something like different kernel tunings have different effects on Ceph, and that won't be so much a Ceph bug as a choice on best tuning practices.
Yeah, I think this is just give we a chance to know these problems, and it depends on us to decide how we do this. Yeah.
Yeah, and right now, keep in mind we're detecting no performance regressions. So detecting some would be an improvement.
Yeah.
Yeah, I agree.
Yeah, the unit level benchmarks will be pretty valuable. I don't think they'll actually, well, they'll catch really gross performance regressions, which will be really valuable. Because those are like bugs that we should have seen in the PR but didn't. So those will be nice. We can also add one for the messenger. I'm hearing a certain amount of silence. Does anyone have anything else?
Through with that one, are we? All right.